Good morning, everybody. From myself and Sean. Sean is unfortunately muted at this stage, so I'll get the whole thing going. Hopefully I don't stuff around. Just a reminder that this morning's Plumbers Tech Talk is sponsored by Heatech, and this morning's discussion or this morning's topic is going to be plumbing ducts. It is something... Morning, everybody. Welcome. This morning's Plumbers Tech Talk is sponsored by Heatech, and this morning's subject is going to be plumbing ducts. And as you notice, if your present or your panelist is starting, then the presenter is muted. So Sean is working away at the background, and then hopefully we'll get through the session without any glitches. Okay. So when we're talking about plumbing ducts, we are referring to drainage mostly, but water as well. Important to note that this is for information only. It's part of the informative annexes, but it's got some very useful information that you could use in debating or arguing in some cases. Your case with architect, designer, builder, developer. So let's get straight into it. Spaces for pipes and maintenance workers has to be adequate. We'll have a look at 673 shortly. The practice of saving space by reducing duct sizes should be avoided, since the difficulties experienced with installation and maintenance are likely to offset any advantages gained. Ducts are accessible from balconies, etc. could be shallow and may be closed by a panel. Metal grid should be placed across duct to each floor to allow for easy maintenance and the placing of ladders where maintenance workers have to climb into ducts. A duct with approximately 1 meter is recommended for ducts that contain pipework on one side, and a width of 1.2 meters for ducts that contain pipework on both sides. We'll have a look at that shortly. The positioning of pipework should accommodate the need for access for rodding and the likelihood of escape of liquid during this operation. In horizontal ducts, the pipework should, if possible, be positioned below all other surfaces. The pipework should be arranged that the escape of pipe contents cannot damage electrical insulation or equipment. So we'll have a look at that. Let me just get my hand out here. There we go. So to start off with, the reasoning behind having a 1 meter duct or having a, in some cases, I mean, 900 is still touch and go, but 900 being a standard door opening, that has become acceptable. If you look at a wire junction and 245 or 1/8 pence, depending on your age, if you add them all up and you've got the 250 and the 2 times 240, you'll see that you need around 700 for the fittings. So unless you're planning on chopping the foundations, which we're not allowed to do, or not, I've seen some chipping away and then you get demolition. So we don't do the demolition, but you need 700 millimeters if you just use these 3 fittings to create or get out from the drain onto the side of the wall for the stack. So the standard then, if you're looking at 1 meter for one side and 1.2, then obviously you're looking at doubling or taking that 480 and adding it onto the other side as well. Then you see that 1.2 is not that unreasonable. So the requirement or the statement that was made in that informative section there says that if you're working from a balcony, in other words, you can stand on this balcony or the stairwell or whatever and platform, you can then work in the shallow duct, because by removing the panel, you can then get to the pipe and work away here. So if you take the same width of that duct and you increase the size and the depth to accommodate the aircon and all the other people that need to hide stuff as well, if you accommodate them, you look at that gap there, you'll see that you need to have the grid that they refer to actually stand on or get access into that duct and work your way back onto the pipe where you need to be. So let's have a look at an example of what it shouldn't look like. You can picture if you get called in here to clear a waste pipe or to clear a blockage in the stack. You can see not only I'm not referring to all the other glaring mistakes. Just look at the duct size here. You can see you're off the ground to start off with, so you need to get down into the bottom of where those fittings are, and you'll have to disconnect and cut and get rid of all this illegal wiring and pipe work and what have you not. So unfortunately, it's common practice for a duct area to become the hiding place for whatever the owner or the developer or the client does not want to see. So you can see here we've got connectors and wires all below the water and the drainage, not separated. Fortunately, in this case, there was no air conducting in that, so you can see it's just all around hassle. So if you need to work in here, it becomes a big problem, and that's not the intention for a duct. So if we look at ducts, this is part of the actual standard, so this is no more information. This is a requirement. It says ducts shall be large enough to allow for the pipework to be fixed at the required gradients without access requirements being adversely affected. Provision shall be made for thermal movement. The ambient temperature in any duct shall be controlled where pipework is of plastic material that could be damaged by a high ambient temperature, or where the flow in any discharge pipe located in that duct is small or intermittent. Discharge pipe shall be installed at least 75 ml from a hot water pipe if it's lagged, and 150 ml if it's not lagged. So let's just pause here for a moment. If we look at this requirement, if you're working in a factory or you're looking at a building that's got a boiler installation with a circulation ring main or circulation system on it, or you're just looking at a factory where they do have high heat, or they have processing areas, or they have manufacturing areas where these issues become applicable, then important to note that if you read the commentary below, you'll see why. If the flow in a discharge pipe is small and intermittent, a high ambient temperature in the duct could result in a dry out. We've all seen old, when you strip out waste pipes or soil pipes, you'll see on the inside there's like a dry film that sticks to the side of the pipe, and it's got all kinds of funnies in it, and then as it dries out, it actually loosens up from the inside diameter of the pipe, and there's like flakes. It looks like big cornflakes stuck along the inside of that waste and soil pipe. The problem with that dry out is that it can lead to a buildup of deposits in the pipe, and thus bringing blockages. So if you have all these flakes loosening up on the inside, and then occasionally you move them by a little bit, or you get them or you wet them with another flush from a basin or something, and it moves along a little bit, you end up building up into something that could result in a total blockage. Consideration should be given to movement caused by temperature changes in that pipework. Adequate provision should be made for expansion, especially in the case of plastics, PG impregnated fiber, we don't see that often, and copper waste pipes, we don't see that often. So the most of the major manufacturers on their junctions or their pipework have all got the rubber joints on the junction, so movement can then, or the movement required is then happening around that area where you've got that fitting. So if we look at that 673 portion and you look at access, in this case you see that there's no access on either of these fittings. You can see by just putting these non-aligned or these not aligned fittings that are under tension here, you've actually got a backfall coming up from the toilet, and being on the same level, you'll notice that these illegal horizontal interconnections go down to that point there with no fall whatsoever. So the only fall this toilet's got is once you flushed it from here, it goes up and it drops that little bit and it ends up lying in this pipe over here. You can see there's some other weird and wonderful connections, soil and waste mixed up, all kinds of wizardry carrying on there, but the requirement is that there should be enough fall on the pipe or gradient or access. We then continue to say that where any pipe is located within a building and it's desired that that pipe be enclosed, it shall be enclosed within a duct. So it's not a question of just haberdashery, just going into one direction and the other and moving things around. it is that you need to have a duct so you can get access or allow for work to be done. The duct shall either be of a size and shape that any person can readily enter in and work in it, or shall be provided with covers that can be removed to enable access to be gained to all junctions, bends, and cleaning eyes. And the removal of any component of the building for the purpose of gaining access shall not endanger the structural stability of the building. Very important that. We'll have a look now. A means shall be provided inside the duct to direct the discharge from any released liquid or matter from that area inside the duct to a point where it's preferably is readily detectable. Should any leak develop inside such duct, any part of the pipe may be built into brickwork or concrete, provided that the interior of that part is rendered readily accessible for cleaning and maintenance. So let's have a quick look here. Quick example of that duct area. Better practice would have you have that duct area at a lower level. And in this case, if we look at 4 toilets at 900 plus a brick skin or brick skin going across, so you end up with 4-meter long duct, 300 mils deep and 1.2 mil wide because of the junctions from both sides. You end up with a sum total of 1,440 liters of water that you can actually catch in that duct area before it floods the office or the house or the building. So if you look at that, my journeyman used to say many moons ago, I think 32 or 33 years ago, architects should design plumbing ducts like this so that the water content can only get to about an inch below the height of a gumboot. I've seen some of these being very deep, and then you need to pump the water, or you need to get an overflow at a proper level to actually take it outside. But the point is that if something goes wrong in this duct, or you're looking at about 140 flushes of a toilet into that duct area before it gets to that overflow level. So like I say, better practice, you're looking at a lower floor inside the duct area, and then when you do have to work in here, you don't end up on your knees with pipes coming out below floor level, because these junctions should be about 200 above the floor level of the building. So it just makes life a whole lot easier, and it gives you room so that if there any pipe work that you need to get from a basin or urinal into that stub stack, at least there's enough height to work with there as well. Typical example of saying we can have a pipe inside a floor as long as it's rendered accessible. So we're looking at, in this case, if there's top and bottom steel, about 40 mils from the top, maximum that pipe should be traveling in that floor is probably about 2 meters or 2.5 meters because of the lack of fall, but then you don't have any access on the side here. So you can imagine if this red line was the start of 110 mil or 230 skin of brickwork, then that would mean that from outside there where the scaffolding is, you'd have to get all the way up here to get to these access points, and there won't be any. Another example of a duct. You can see by the depth it's quite a nice duct, but now you need to go clear a blockage in a stack, and you need walk into this nice white kitchen, and I don't see any screws in that on that panel there, but you need to remove this panel, work away in Mrs. Jones' nice white kitchen, and then start putting back all of this here without spilling any liquid, without getting your tools on anything there. So yes, it's a nice big duct, you can see by the size, and it probably only picks up the kitchens or the dishwashers in the kitchens, but not very practical. And then in the absence of any ducts, you're looking at something like this, where you have soil and vent connecting onto the same drainage system. For the guys that attended 10252 part 2, you'll know that you either have all the soil running together or all the waste running together. What should have probably happened in this area is if you had a proper plumbing duct, oh sorry, a duct is horizontal, we're talking about a service shaft rather than a duct. If you then end up going up at this level and you're actually collecting inside that duct area with some access there, we're probably in a better job. Another example of what it should not look like. If you couldn't get a drill in there to fix your water pipes and all the rest of it, good luck in doing maintenance in that little slot there. Okay, Around ducts, a drainage installation has to satisfy the performance criteria given in 443. 443 mentions that you need to have access, it needs to be quiet, it needs to be leak resistant, needs to be vented and all. So a drainage installation has to satisfy those performance criteria in the most cost effective way, the cost of maintenance being included. So the layout of the fixtures around that duct has a direct influence on the layout of the pipework and the cost of the installation, and therefore has to receive special attention when the building is being designed, particularly with regards to group of fixtures around ducts. Where possible, fixture entry points should be closely grouped to allow the speedy combination of discharges from the various fixtures. In other words, the closer to the stack, the easier it is for all these waste pipes and soil pipes to end up inside that stack, and the easier it will flush and you'll have a proper system working. This will assist with the flow of sewage and result in economical water supply pipework at the same time, and discharge pipework from sanitary fixtures. In large multi-story installations, the rational layout of pipework could become crucial, and the following may be useful. So when you're discussing this with a developer or a designer or anyone, then you can actually have a reference to the annexes at the back of SANS 10252. You group the fittings close together. You group the facilities and locate them back to back around pipe ducts, which is normally the case. These simple layouts will reduce cost, improve hydraulic performance, cut down on maintenance, lend themselves to prefabrication. In other words, you could end up in your workshop putting these things together. And then we have a look at just delivering the material and the guys on site installing. Place water closets as close as possible to the vertical stack. The closer you are, the better the fall, and the better you end up getting your gradients into the stack. And then very important, you position fittings with low level traps. In other words, urinals being slab urinals, baths and showers as near as possible to ducts to accommodate pipe falls more easily. So if you do have any of those fittings, especially in sanitary groups around a stack, that means that your showers, baths, okay, we'll skip urinals for that matter because very few people still use slab urinals. When you're looking at bath and shower waste, the closer you are to the duct, the more sure you're going to be of getting your pipes and your fittings in there. Avoid short offsets around columns, etc., and short radius bends, very important. There's no sense in having a 2 meter by 2 meter duct area where you can actually climb into the duct, have this nice galvanized rector grid with step ladders to go from one level to the other, and you open the IE and lo and behold, just inside that IE there's a 90-degree plane bend, or at 245, or an offset created by 245-degree bends. And you can't gain access in any event. So the whole theory is you keep it long radius, you keep it as straight as possible with the access inside that plumbing duct. You'll be able to get to that the fixture on the inside, and from the fixture side, if you're plunging on the shower or the bath trap or even the basin trap once it's built into the wall, or the waste is built into the wall, then you end up getting access from both of those points there. So inside and outside, obviously a far better job. Typical example of how not to get them in a knot. You can see if the whole bathroom fits into that area there. That means that once you've gone up into this IE, there's got to be a 90, because if this is the toilet, then that shower or that bath or that basin can't be right on top of this here. That means there's either going to be a 90 bend or a 45 bend or a long run towards where the actual fixture is on the inside of the bathroom. So what that clip from that information was saying is that if you are going to have this, then this should be going straight to wherever you're aiming at, not have extra bends or offsets or move them around within the concrete, because then they become inaccessible. When the information section says you need to position toilets close to the duct, it does not mean that you end up having interconnections. See, the one on the further side had to be raised to get that fall to go into this duct area here. So now you've got an interconnection on the horizontal picking up 2 toilets. This one you can see by the tiles there, it's already got a backfall from where it starts. So having them positioned close to the duct means nothing if you can't get into your stack without any further hassles. It's not only the brickwork ones, the guys that do the office fitting or the what do they call, like internal renovations in that. When you do offices or you do these bigger buildings, you'll find a lot of works being done by with drywalling. Here's a typical example of interconnection on the horizontal coming from the toilets. So once that piece of drywall goes onto this section here, there's no access, there's no proper gradient on this thing here. So every time there's a problem, and even if the manufacturer says on certain of these fittings that you can remove the pan, that is going to be short-lived. But even if you can remove the actual pan, then you've still got no access through this 90 here going both ways on this specific line here. So it's not only brickwork, panels and ducting, the same applies to drywalling. Another typical example, no access, self-created trap, no access. So you've gone through the exercise of buying a proper junction instead of a strap-on saddle, install the junction, and you still have no access onto those fittings as it is there. You can see there's an offset in the stack as well, so it might be a noisy stack deck. Here you can see plastic pipes not fitted, so it's like hiding space for whatever happens, guys. And if you look at the one next door, same thing applies. Here you've got a trap or self-made trap from a geyser tray, not acceptable. Wherever that goes, it probably picks up another waste or another tray. You'll see all of these funnies happening. The problem is that once you start dealing with ducts, yeah, you can see this one was done on the horizontal, everything connected onto one pipe with very little fall. And then when they did the extension to the building, they actually core drilled and they did a proper job, and they connected the toilets and they dropped through in the drain and it went through to the drain. So you can see there's how not to do it and how to do it on the same sheet. And this one here, you can see 45-degree soil and vent bends, can't route through those. And then if you consider the brickwork on the outside of this cast iron frame here, you can only imagine what happens to this pipe work here and how many offsets and how many kinks is on this thing before. So getting access into that stack means very little when you're looking at gaining access or cleaning something and your rod stops here or your access stops right here. Then whatever happens here with these other junctions and that under the ground is an issue. Something to bear in mind before I start taking questions, when you're looking at plumbing ducts on site, a plumbing duct, like I said earlier, becomes a hiding place for all and sundry to put whatever they get to the fittings. So if you have the drainage guy, the electrician, the solar, the DSTV, air conditioning, everybody's aiming for that specific hole. Then it becomes a problem because you actually need to start looking at what is, there's only space for X amount in that duct. So see the first question, how are plans passed at town planning when these service ducts do not meet the requirements? Good question. I'm not 100% sure. The same presentation was given to the BCO yesterday, so hopefully we got through to a couple of them. It is something that is an issue at this stage. I know there are presentations being made to architects, and we're trying to inform everybody, and we're trying to get everybody on board for, or get everybody on the same bandwagon, if you want to call it this. So yeah, it's difficult to say what happens in each of these local authorities, especially the smaller ones that we don't get to. At this stage, we are, like I say, we're doing presentations to the architectural professionals. We are talking to BCO. We're trying to get these things out here. But the one connection that we do have are the guys that are in the room at the moment. And if you are on site and there's a query, there's no reason why you can't reference. For the guys, I keep getting messages around these presentations. If you go onto your plumber's app, you can go to products and standards or something at the last column at the bottom. You can access these things. You can actually show these slides. You can mute the thing. They don't even have to listen to me. Just show them the slides that are on there. And while you're on site, discuss with the client, discuss with the architect, discuss with whoever is responsible, so that when you do need to get the building signed off at the end, then you don't have any problems. See, the next question here says, what about Kibberet drains? Okay. There are currently negotiations on the go between not only that company, but about 4 or 5 of these HDPE companies. They are looking at standards. These, what do you call them? The manufacturers have come to realize that more and more of their installations are being failed, because the more information gets to the building control and the more plumbers are informed about the non-compliance of their system, the more they have to work on these things. So what they are doing is the request from them to actually meet up with IOPSA, PIRB, some technical representatives, and even representatives from the SABS, means that everybody's looking for a way to make the system work without getting involved with all the other details of each and every other municipality. If you can get the manufacturer to comply, then it solves all your problems. So we are busy talking to them about it. And the first thing they tell you is that they do have access T-pieces with end caps, but the guys are not using them. So that's the getaway at the moment, but we are working on that. Next questions, how are the regulations being introduced to the professional team? Majority of the time, architects and mechanical engineers are unaware of these regulations. Okay, it varies from area to area. I happen to be registered as a architectural professional as well. So I can tell you that they have got their own bodies, like we've got PIRB, they've got SIAT, they've got SACAP. They do these CPD presentations. I know I've actually sent some of my stuff up to Nick Joubert from IOPSA. So I know from IOPSA side, we're trying to get everybody on board. And then when we do have the regional meetings for these architectural professionals, we get invites, or some of us get invites. I know Rudy, what is that? Rudy's in Mossel Bay, I think. Down there, they've actually met with the municipality. So guys, this is like an ongoing thing. We're trying to connect to as many people as possible. And we're trying to get as many people as possible involved in the whole setup, so that we can inform them, ask questions, help them. We've got guys down in Cape Town. I think they've met with the locals there, and they've met with the municipality. So it's an ongoing thing. As long as you guys in the room are comfortable that you've done your bit and that you have informed, then at least we're getting somewhere. So that is it. If there's anything else, or there's any other questions we haven't answered, if you sent it in, it'll get sent by email, and then we'll respond to that. So keep safe, guys, and see you next week, same time, same place. Cheers.